So I'm so glad I'm here. So what we are going to see today is, as you already heard, my name is Srđan Nalis. It's a Croatian name, very hard to pronounce, so you don't even need to try. And what we are going to do is, I'm going to show you how we implemented service virtualization at scale in one of the largest, if not the largest, telecom in the world. And this is the case study and service virtualization approach and testing approach for British Telecom. So me, myself, I come from the company called Perforce. So Perforce partnered with British Telecom to deliver this solution. So I'm mostly going to talk about how we did it and what is the approach. I'm not going to do some product placements and stuff. You can come to our booth and we can definitely talk about our solutions. So first things first, my marketing asked me to do this. If you want to get into the giveaway for AirPods, you can scan this, QR code. And this is if you want to contact us. I will leave this on the end of the presentation as well, if you obviously like what you see. OK, so let's get started. A little bit of introduction and things that most people in this room would know is how the evolution of testing actually changes with the evolution of the applications that we are actually building and we are using. So first of all, obviously, everything turns into digital landscape. Everything has to do with client-side applications, and client-side applications then have so many APIs behind the scenes. And actually, if you want your product to be competitive in this market, you need to have, the more integrations you have and the more API integrations with third-party systems, this is what makes your brand recognizable. And then obviously we had rise of the client-side performance testing. So how do we test on these React type of applications and similar applications, and how we test on mobile and web, and there is more and more and more. And many famous brands, and some of these are actually my customers, they neglected this kind of testing, or especially neglected how they test when they don't have available or third-party system components to actually integrate. So these are some of the problems that actually happened in the market, especially very popular these days is the European concert of Taylor Swift, where our friends in Ticketmaster wanted to sell tickets for the event, and in 5 minutes of opening the event, purchasing, the whole site crashed because there was like 3 million users trying to buy it in the first 5 minutes, you know, so things like that. So how do we actually test, and where we see the possibility of transformation and how we shift the testing left is actually by introducing service virtualization. And service virtualization for many organizations is like, even today, oh, it's a niche technique. Maybe I will use it, maybe I will not. I don't know how should I or not use it, and would it really help me and save money, save time to market, save cycle times and everything else. Now, also in the past, service virtualization is something that we as a QA people, we always say, oh, service virtualization is something the developers will do, you know, and they don't give us access really to that, and I can't really test, but so maybe I can put up some basic mock, and then in that mock I can do some testing, and it will be a static mock, so let it send some same data. Every time I hit it, it will reply with the same data, and that's my use case, what I'm testing. And basically, what you're missing many niche use cases and ways how you can actually make your testing robust and how you can really check all the edge cases for your application. So with that said, we are going to talk about application from British Telecom, which is a mobile application, which is called Spam Shield application. And basically what Spam Shield application is, it's an application, or how they call it, BT Call Protector, which helps BT customers, enterprise and private customers, how they can do call filtering, number blocking, how they can do caller identification, and how generically they can stop spamming and like fraudulent calls on their application. But one of the very niche use cases, and something that is so important in telecom industry, is the one that we focused in this study, which is SMS spam and fraudulent SMS blocking. So this is the focus, what we did with our friends in British Telecom. So now, if we look at their landscape, this is something how this is just, how to say, short abbreviation of whole infrastructure, because there's no way you can draw a painting, a picture of this and actually makes any sense, because it will be so complex. So what you see here is we have Spam Shield front end, and then we as the testers have Spam Shield backend, and then we have internal dependencies, and we have some data stores, databases, then we have authentication services, mobile gateways, some services that are done by other teams, and then behind the scenes here, I just mentioned some of them, there was around 50 different third-party integration services that were behind the scenes. Some of them are messaging services, Salesforce integration, tracking service, billing service, and many, many others. So now when the QA teams of British Telecom wanted to test this, and by the way, this Spam Shield model is actually AI ML model application, so it needs to be trained before it is being put into production. You need to train the model to recognize what it's going to do. Now, we need to do testing, we need to check all the APIs, we need to check performance of it, we need to train the model, and then we have a picture like this. This is what was available for that team to test. So first of all, all of these integrators that are third-party integrators, they were having different cycle times, releases, nothing is deployed at the same time, data is not available. If it's available, there is not enough data, or data is productionless data that we'll maybe need to mask, and we will need to make virtual copies of it. And then internal systems are used by other teams, and so forth and so forth. So the idea was, how do we actually build a plan and build what we want to achieve, and how do we actually are able to test something complex as this? So we came up with two approaches, or let's say two goals and two objectives. First, we had project objectives, where the team actually identified what we need to achieve with this application. So we need to identify what is the most volatile messaging and scamming we want to protect and we want to stop. We then wanted to provide customers with the application that is as accurate as possible to stop the fraudulent messages, and train the model to recognize what is a real message and what is not a real message. Because the worst thing you can do is you get some two-factor authentication from your bank or something like that, and I block that message because I think it's a spam. Or vice versa, if it's a spam and I say it's your bank, it can be quite complex and quite problematic. Then we wanted also that the model is able to anticipate attacks and basically understands how the attacks are coming and wants to have a zero-day vulnerabilities when it goes live that actually works what it should work. And then we also wanted to, as I said already, successfully train the platform to recognize all those patterns and everything else. So these are the project objectives, what we wanted to achieve with the Spam Shield application. Now we had project objectives, what we want to do for testing strategy. So the first thing in testing strategy is we wanted to set up virtual services for every single unavailable service, and we want to set them up with the predictable condition and predictable data, so we can actually use virtual services not only to test the model, but we also wanted the responses of a virtual service to train the model about volatile spamming and other fraudulent messages. So basically, virtualization not only to be used for testing purposes, but also the responses of the virtualization and data that is coming from virtual services will be used to train the AI model on different patterns. The next thing we wanted to do is we wanted to test API services and all the APIs we want to test from the API level, hitting the virtual services, but also hitting the available services that are in the play. Then set up performance testing, obviously measuring all the latencies, 95, 99% align response codes, and how quickly the service or Spam Shield will work. And then most importantly is because British Telecom has fraud and operations teams, which are not part of the QA, but they are actually part of the Spam Shield application, is also to enable these stakeholders how to use application, to understand the possibilities and everything else, and also to give us advices how we can do additional testing because of their knowledge of the application. So these are the goals, and this is what we wanted to achieve. And then the result, we wanted to get something like this. We did it with our product called BlazeMeter. I'm not going to bother you what BlazeMeter is, but it has capabilities, among other things, is to build very robust virtual services, and also has capability to create synthetic test data that you can actually inject and drive your services as dynamic services. So every time you hit a service, it will respond with a different set of data, and then you can predict what that data wants to be, and you have an AI model who can build that data for you based on any rules you specify. So this is how it works. So this is like a very simplified version of what it is, right? So how did we actually deploy that? Once we build the virtual services, we also deployed it through Kubernetes and Carpenter implementation because we wanted to have virtual services not always up and running. We wanted to have them on demand. So basically, let's say if I'm building a virtual service, which is going to be used as a part of performance test. Now I'm running a performance test of 50,000 users. I cannot host that service on a single node or on a single machine because it will crash and it will not sustain a load like that. So based on what the team wants to achieve, I'm running today performance test, or tomorrow I'm running API tests and stuff, Kubernetes will do the provisioning, and Carpenter will determine, do we need more nodes? Do I need more CPU power? I don't know if you guys, by raise of hand, everybody's aware what Carpenter is? So Carpenter is a open source plugin for Kubernetes that enables you to automatically scale nodes based on computing power you need. So it will add more CPU, it will add more nodes and things like that, but it will also shut down nodes that are not in use. So you want to save on infrastructure as much as you can, so basically you just bring these things on demand. So this is how it's actually built. Now we come to the more, I selected these, there is more, but due to time I don't want to bother you with many other, but these are the edge cases that we wanted that virtual services can handle. So now every API testing, every testing of the service and everything else, obviously we want to measure the response codes. We want to measure how those response codes for both negative and positive scenarios, because the worst thing you can do is actually only test happy paths. You also want to test negative paths. Our synthetic data generation model also allows us to create negative paths. So let's say we also, in this place, we also tested something called billing system of BT, which is part of this spam shield. But we also tested billing system with sending him expired credit cards with the wrong, I don't know, PIN codes or things like that, and we test those negative scenarios as well. Now, the next thing which we also test, we test actually conditional routing. I will speak about all of this individually. So how we tested different redirects, different A to B use cases and things like that. We were also needed to test different certifications and certificates, and as we call them, SSA aliases. So basically, if I send a certain certificate, I want to get a different response from a different part of a virtual service. So basically, mimicking which certificate had access to a different third-party system. So I can actually get those responses. And then last but not least, we also test XPath and C data validation, and I will talk about that, what that actually means and why we needed to do it. And then we also implemented a logic where we can deploy multiple virtual services on a single port. So basically, you don't need to have one service, one port, which is usually the case with the services. We deliberately added multiple services on a single port, and then depending on redirects and where this traffic goes, it will hit different service. Just to mention, before I talk about virtual use cases, and we ended up with 200 virtual services running 4.75 million transactions, mimicking all of these third-party systems. Okay? So a little bit, just very high-level information. I'm pretty sure everybody in this room is aware of this. So what we are seeing here is what this actually means, dynamic testing of responses. So you send the API call, sorry, I'm moving the mic. You send the API call with the request. You have dynamic response logic on the virtual endpoint. And basically, if you get 200 normal messages, 400 messages, 500 internal messages, going back and forth, the line should go that way as well, I'm sorry. And basically, you are testing different logics, error logic, circuit breakers. Is the application able to continue when it gets 404 negative message and things like that from the non-available systems? So this is testing the dynamic response codes. Then we were testing conditional routing. This is what I was talking about. In the virtual services we build, not only that we can specify what is the request and what is the response, we can also, like in a real service, we can set up what are the headers of the service, what is the payload of the service, what are even processing actions of a service. So meaning processing actions, I can also make this, many of these services are actually stateful services. So they incrementally increase, let's say, logic, they send different data, different response. So basically they behave as much as possible as would the real service behave. So let's say in this particular case, if I have a header A and I go and I have the certain rule, I am expecting response A. But if I have a header that has a different geolocation, and for example, I'm sending AU location, Australia location, API ping, I want to get a different response from that region or things like that. So this is the condition. Obviously, BT Spam Shield only works for UK market and AU market. So when I said I can use Australia, I can't, but I was just giving the example, okay? Okay, now SS aliases. This is basically nothing more. It's a fancy name to how to test certificates. So somebody told me that they call this SSA aliases, and I said I like that name. It's much better than just cert or certificates. But basically, you are sending requests with different certificates. They can be SSO certificates. They can be auto authentication 1.2, 2.0, whatever version. We can apply that logic into the virtual endpoint. And basically, if I send a request to the virtual endpoint with different certificates, I want certificate A, for example, to simulate some partner API, and I want that to be returned to my application. If I have simulation alias B, I want this to come from my internal payment system. But I don't want to have multiple virtual services to do this. I want one service to handle the requests and aliases, and then invoke another service and make dependency if he needs to fetch the data from it. We can even do those kind of things as well. And then last but not least, why we implemented XPath and C data XML testing. We had a lot of XML payload from the old legacy systems of especially billing systems. So we needed to test the XML logic. And these XMLs are, like for payment and billing systems, are very big sausages of data. And sometimes we wanted to test data as literal, like a C data, but sometimes we want to test XPath logic, which actually can also include regular expression and stuff like that. So we wanted the service to understand how to interpret these messages. Don't interpret them always as a regular expression, as XPath, as this. Interpret them as literals. And the reason why we needed to do that, because this XML logic for payment system is several years, if not a decade old. So if we didn't test this edge case, we will end up with the problems and defects that are deeply embedded in that XML structure. So that's why we needed to test this as well. So these are just use cases, very high level. Obviously, if you want to see a demo of this or we want to discuss it further, we can definitely schedule this with you. Now, just a little bit of part of the product. As I said, I'm not going to talk about the product. This is one thing that was very important from the day one, is because, as I said, we don't want to build static mocks. Like, obviously, there is tools like WireMock and Mockito and similar tools, which you can use for this. But what we want to do is we have an AI model who can be trained to build any set of synthetic data that you can then inject into your system under test, into your test itself, and also into the virtual service. And you have then data consistency across all three entities: a real system, your test, and your virtual service. And how this data works is you can literally work with AI model or manually. If you cannot, any AI feature we have in the product, we can switch off. Because there is a lot of, I know a lot of you work in organizations where AI is still not regulated and you maybe cannot use it. So if you can, we will switch it on. If you can't, we will switch it off, okay? So basically I can say to the AI model, you know what, I need usernames, let's say first, last names of users. I need you to give me those users' addresses. I want addresses in London. It will create London addresses. I want you now to match zip codes to those addresses. I want you to give me a profile of Visa account, phone number, phone type, and I want you to build me that model. And AI will build that model and display it to you, and then you can just say, I want 5,000 records, 10,000 records, 1 million records. And it will create unique, and you will just inject it into your test, and you will inject it into virtual service, and then you can test these permutations. You can then choose to leave the data model static, or you want to change it every new hit to a service, you want a new set of data. You can do that as well. And then just a little bit about API testing. So basically, not only that we did API testing, we actually did something called also API synthetic monitoring. So how is this different than doing API monitoring with APM tools? In no shape or form we want to fight or challenge APM tools like you probably use Dynatrace, New Relic, Datadog, and all these tools in your daily life. And obviously these tools are useful for monitoring and everything else. And we don't compete with them, we integrate with them. But how is this different? We build API test cases that run against these virtual service / live systems that are available. But we also took the most critical API functional test cases and run them on regular cadence against the live service as a synthetic monitor. So this was the approach: test once, monitor always. So I want to see when that service was live, I want to see how often is available, I want to see what is its response codes, and I want to see what is the data integrity. And then I want to build me a dashboard, and if you can see here, I don't know if it's visible, like for this service, everything was green, and then it failed here. And I can go through time and see why it was not available, and what is the percentage of availability per month, per day, per everything. So this is the little bit of difference of synthetic monitoring. Okay, so what did we actually achieve? This was done a year and a half ago. So this system is in production as we speak. So basically what we know about this system at this moment, we know that error rates in staging, when we had some problems, defects, error rates, system couldn't handle it, they dropped after implementation of this by 87%. We were able to reduce cycle times of testing from 10 to 2 weeks because there is a lot of testing behind. I know 2 weeks sounds really a lot, but you need to test the logic of almost 50 different systems, right? And then we also created synthetic SMS loads. We were mimicking SMS farms or real how to say, SIM cards, sending data back to the spam shield, but it was done by virtual service. It was not a real phone sending messaging. We were sending it from the virtual services. And then when we tune all this up, we improved responses per second and the whole tuning of performance of application 5 times. Now, these are good numbers and let's say quite impressive numbers, but they don't mean anything to the stakeholders. So now I'm going to show you what happened when we moved Spam Shield into production. So the data you're going to see is in the first 4 to 5 months of working live in the production. Okay? And this data is published on British Telecom website. It's published by newspapers in UK. So this data is publicly available. So everything I'm showing you, it's also publicly available. So first thing which is important is that there was, in first 4 months, there was 93% reduction in customer complaints on spam initiated or received after the application is enabled. So this is 93% down in reports of spams. We blocked successfully 280 million spam and fraudulent messages in UK in first 4 months of work. And then we had over 1 million incidents that we stopped per day in given locations in the UK. And one thing that I personally am the most impressed by, because this model was trained on a virtual service, the model was 97% accurate in stopping fraudulent or releasing real pure messages. So basically imagine for every 100 messages received, it stopped 97 of them if they were fraudulent. For something that was trained on a dummy, let's call it virtual service, it's quite impressive to get some data like that. So this was very important for us, and it was very important for British Telecom. I think, if I'm not mistaken, you cannot download this application here, but if you look at the UK data store, and don't hold me for word now, I checked it some month ago, but I think it had on both Apple and Google Store, it had 4.8 or 4.9 stars as application, which you want to see for your application when you download it, right? So this is the business impact of this particular solution. Now, a few more things which I always like to give as a takeaways and something how we did it. Usually somebody will stand in front of the potential customers or prospects or everything else or existing customers and say, oh, we did this in 3 days. It's so easy. These tools are user-friendly and things like that. I always like to say they're user-friendly, but they're very selective who their friends are. Okay? So let's say when you implement this, it doesn't really take. It takes a lot of time. And we implemented this. It took between 4.5 with some tuning, almost 6 months to deploy all these modules. But once they're deployed, the savings were tremendous. Like spinning up new environment. I didn't give this data because there's much more data behind. But let's say spinning a new service took 1 minute, right? And initiating performance test against it is 30 seconds through a CI/CD pipeline, right? So once you have it and when it's templatized and everybody can piggyback on it, you can do wonders. But it takes time to deploy something. So what really worked in this situation is the first part of this is start small. Like we could set up and set and say, okay, let's virtualize 50 or 500 systems at once. It will take 15 years, right? So what we did is we took the most fraudulent and most important systems and each edge use cases we wanted to achieve, and then we actually first and foremost virtualize those, which are the most important components. Now, with this approach, we had also problems talking with the stakeholders from the business side. They said, okay, is this really going to, okay, I understand my team is saying to me it's going to improve my quality, but is it going to really to cut my costs? And the answer, we did the ROI calculation, and I can share that with you as well because it's a very robust model as well. But there was savings of millions of pounds if you actually deploy this on real systems and waiting for them to be deployed and getting hardware and all these things, right? So then they said, okay, go, do it, like I want to see it in action. Now, we also have we learned from this exercise with British Telecom and a few other companies where we did this. We learned how this model can really work if you are building modern applications, if you're building IoTs of the world, and if you are moving to cloud native deployments. So basically, let's say anytime we do this with organization, it starts with a very painful approach. It starts with a lot of resentment. Okay, why did I went this route? And then when it's deployed, oh, I want to go and talk to everybody about this, and can you introduce me to all your clients? And I will talk about them how good this is, So this is like 4 stages of grieving, but 4 stages of testing, right? I'm very nervous. I don't want to do it. Then it's great. Let's talk to everybody how we actually did it and how it actually works. Okay, and then also we needed. This is from my point, from technical view. This was the very important step here. Because we needed to get an alignment with developers, with third-party vendors, and we needed to get the QA alignments, is actually what are the data formats that we are going to drive this request-response matching? What is exactly the data we are sending as a request and what we are planning to get as a response? And would that help us train the AI model in the right way? So this also took a lot of steps. It took a lot of talking to developers, to the data team, to everybody else to tell us exactly how to build these data models. So that takes, in those 6 months, probably this took a month and a half just to articulate the data. Because we're talking about 4.75 million transactions, and each one of them is driven by synthetic data. So you can just imagine how many messages are coming back and forth every single day, right? And then last but not least is, we also spend some time upscaling different teams how to maintain this model and also how to expand on this model. So when somebody tells you, okay, how hard is to learn your tool? It's not hard to learn the tool. And I promise you it's user-friendly really. But you need to know underlying technology. You need to know how API works. You need to know the logic behind different edge cases. And this is something that we also spend time training the team. Not just how to click buttons and use tools, but what the logic of a service actually is doing. And this is what we build. And we build champions, obviously. Some of those champions, because of these projects, actually became chief architects in the organization. So we actually work together with them, not only to build the great system, but also to promote their knowledge and make them successful as well. And then a little bit bragging as my last slide, so I want to brag a little bit, so sorry to do that. So this project won several very prestigious awards as the best telecom and the best IT project in Europe. And also it got the best telco project in Asia Pacific in 2024, 2025. And it got also a reward of Royal Grant of UK government for the best spamming and fraudulent software in the United Kingdom for year 2025. And this on the picture are the proud team members from the British Telecom, and obviously me pretending to be James Bond in the middle of them. The only thing I hated is because it's a black tie event and I have a thick neck, so wearing a bow tie never works for me, yes. So basically, this is the slogan that I actually built. I actually dropped one part because Cameron said, is it too presumptions? And I said, okay, I will drop it, but I will then tell it. So basically, this BT team actually likes to say, simulate, accelerate, transform, and then the last part was dominate, and I really like that. So basically, that was their slogan, and basically, they were so happy with this. They actually named their team by this slogan, and the short name team is BT Autobots. You know, so they are like transformers because they can do everything with this service virtualization. So just wanted to give you a very high-level overview how this is done. There's so many things behind the hood and behind the scenes. Definitely happy to talk about this and other implementations. We also have implementations of similar solutions in Australia, in some of your biggest companies. So if you want to learn how this model works, you want to talk to us, as I said, just to show you how virtualization can help your testing efforts, please, again, going back to this slide, if you want to talk to us, contact us by the link before, and if you want to get into our giveaway, please scan the QR code. I plan to leave between 8 and 10 minutes for questions, and first time in my life I'm probably on time, which is great. So any questions or any comments about anything, and please, if you like to ask away. Okay. Did I confuse you all? I'm sorry. I'm just giving the mic so we can record the question, and then I can speak on this mic, right?
Thank you.
Yeah, okay. So let the gentleman first ask a question, and then please.
Yeah. Oh wow, that's strange.
Okay, that's loud. Yeah. Move it a little bit. Yeah, exactly. Yeah.
Okay, I may have missed this, but on the slide where you had a diagram describing the issues with the testing environment, the Smart Shield or Spam Shield front end and back end were marked as unavailable.
Yes, that's a very good catch.
Why were they both unavailable?
They are unavailable from the UI level. So we actually trained the model through the APIs. We were sending the API calls until the UI was ready, right?
Okay.
So when I said UI was unavailable, the physical mobile app was not available because it was not designed yet, but we had the APIs.
Okay.
So let's test it on the API level. When UI is ready, we tested it on real devices and everything else. So that's why I said it's unavailable.
Okay, yep.
But very good catch. Any other questions? Yes, please.
When the system went live at BT, you had a slide that says, you had X number of spam messages that were blocked. Because this is an AI-trained model, what verification was done to authenticate that number? Because if you've trained it, yeah. So when you say you blocked 40 million fraudulent messages.
BT used something from the company called Maverick or something like that. I'm sorry, I will talk here. So basically, how the verification of AI model was built, it was actually verified by this fraud and operations team that I mentioned, and basically not by QA team itself. And they used some tool called Maverick because it's the same thing like Top Gun calling thing. I was expecting Tom Cruise verifying this for us, but he wasn't. So basically, they had the previous data from the previous spam shields, and then they compared nodes to nodes based on that tool capturing. And then this tool had, let's say, if I understand it correctly, and please don't quote me on this because I'm not a telecom expert really, I just know virtualization and stuff, but in telecom there is a set of rules, like you remember in the past we had a set of rules for VPAT testing, for example. So you need to make this happen, this happen, this happen, this happen, and maybe somebody here is from telecom, he can help me. So basically what they did, they map on those rules was those rules applied, successfully stopped, and everything else. And then measure by the statistics they had previously. And also, I think it's called Maverick, if I remember correctly. It's also used by other telcos like VMO2, Vodafone, and so forth, so they can compare historical data and get those numbers. But there's a lot of data science behind the scenes. I didn't got these numbers, I just got it from them. So, yeah, cool. Yes, sir, please.
I think we can all agree that we hate spam, so congratulations on that. But behind this, there's a commercial model and hopefully an ROI for BT. Can you talk about that? Because the numbers are truly huge here. You know, do we have a model? Simply, I can think in terms of lost minutes in the people acting on that spam. Is there a sense of what the ROI was?
Yes, so ROI in pure money, shared with us by BT and also available on their website, is that we help BT generate the revenue and save revenue and product brand. I think in the first 2 years of deployment, it was around 46 million pounds. That was the revenue gained from the Spam Shield application and savings. I don't know the separation between savings and revenue, but 46 million is what they shared with us. Pounds, million, yes. By the way, don't think the deployment of this is even fraction of that price. It's not even close, yes. Thank you for that question, actually. By the way, that's my team member, but I didn't pay him to ask me. Excuse me, sir, do we know each other? No, you never saw me before. Let me show you this card trick. I'm joking, go ahead, sir.
I've never seen him in my life.
Yeah, I don't know who is this gentleman. Please escort him out. I'm joking, go ahead.
And I'm genuinely interested.
Yeah, you're right. Very good. Very good question, actually, yes. Guys, anything else? We have a few more minutes. Yes, please.
Hi, I'm just wondering, how did you get the data so right with the GDPR and important regulations that are in place in the European and the UK region? The whole success of this implementation relies on the test data that you fed, and just curious.
That's a very good question. So first of all, we had different approach planned. So one approach was, okay, should we go and see if we have any production data on this, which was very scarce. And if we have it, should we mask it and maybe virtualize it and dump it into the model, right? Mm-hmm. And, try it. Unfortunately, we didn't have almost any data. Mm-hmm. But luckily for us, we had data scientists and people who work with this similar data in BT previously. Mm-hmm. And they create schematics and models of data, which we then apply to AI to build data based on those rules. Mm-hmm. So very small level example. Let's say if you are building let's say UK driver's license. You need to have a first name, last name of a person. You need to have, if it's a male or a female, you need to have a date of birth, social security number, I think last 3 numbers, and then you need to have a capital letter and at least 1 3-digit number from something else. I forgot what it was. And then basically we give all these permutations and concatenation to AI model, and he says, okay, I understand the model. Here is what I throw out. Now, to give it in a simple ways, let's say you want to build a Visa credit card number. Every single Visa credit card in this world has 20 digits and starts with the letter 4, right? If you look at it. So basically, that's how we train the model. We tell him, okay, this is what we want. So now he creates the data. Let's say I have a John Smith with this social security number, this driver's license, and this Visa credit card. Now, does it look like a real John Doe? Sure. But it's still synthetic. I created synthetically, so it's not applicable any GDPR or similar laws to it. So that's how we were able to do it. That's the only way how to do it.
All right.
Does it make sense?
Yeah, it does.
Mm-hmm. Cool.
Thank you. And other one was, you mentioned synthetic tests being run in production.
Synthetic monitoring.
Yeah, synthetic monitoring. Could you please tell a bit more about those tests and at what scale those tests were run? Was it just
synthetic monitors are nothing more than let's say when I deploy the APM tool usually on my production system, I'm monitoring what my customers are doing with my system, and I'm seeing availability based on the monitors and agents that I set up. Most of the APM tools work like that. There is some permutations, obviously. But what I usually don't do in production, I'm waiting to customer to perform something to monitor it. In this case, we selected X number of most critical things that customer can do, And then because we have a functional test of it, we schedule that test, single test, running all the time, just to tease the model to see if it returns the real data, is it up and running, and what is the response time. So this is the synthetic monitoring. It's a combination with that and API monitoring together, but we just want to ping these, let's say, very stupid, 10 tests. We want to run this every 5 minutes because I want to test. That's the most critical thing. You must be up and running, right? From a functional perspective. Then I can run performance in production, which we also achieve. And you can do also performance. We did performance testing on different geographic locations. So we set up one model to run from Frankfurt, Germany, because there is options for there. Then we set in London, UK, then one in Belfast, in Ireland, then one in Scotland, things like that. So we want to simulate that these messages and everything is coming from these locations as well. Yeah.
Thank you.
I think, yes. So what I'm going to do is, if I find them where they are, oh, sorry. I don't know where I put them. They were here just a minute ago. Oh, there they are. So I have some of these certificates. So basically, they're $50 each, right? I almost said $500 and put you in minus, right? So yeah, so they're $500 each. So I just want to. The idea is I will ask a question from my presentation. Whoever answers it, we can share it. So just wanted to ask. Okay, let's ask a first question. Very simple one. What was the name of application that we were testing? Please. Yeah, okay, so one for you, and I have one more. I'll come here. And then the last thing is, it's a little more complex, but it's not that much. What is the name if I have a service that actually needs to change the data or the service during the execution? So basically, when I send it, it changes its something to return something back. How is that called? No, that's not carpet. That's a version. How it's called the type of service that can change. I won't say what because that will give it away. Okay, I will give it away. That can change the state of a service when it returns the response back. How is that type of service called? No?
It's conditional.
It's called a stateful service, but you were close enough. So let's do it like that. Yes, it's conditional, exactly. Yes. Thank you. Here you go. Thank you so much. Thank you. Thank you, guys. That's it from me. Hope you enjoyed it. Thank you.